Hello, everyone, and welcome to the Data Science Fellowship Cohort 8 Demo Day Showcase. My name is Val from ayedge.org, and I will be your host for tonight. It's TGIF ngayon. Thank God it's Friday. It's a Friday night. You could have been anywhere else, but you chose to be with us here tonight. And for that, we are so thankful from the bottom of our data-backed, research-based hearts. Before we start our event, Angela Chen, CEO and co-founder of Eskwelabs, will start us off with her welcoming remarks. Please watch this.
Maganda gabi sa inyo lahat. Thank you for joining us for the Eskwelabs Data Science Fellowship Demo Day. And what a strange time it is to be in the world right now. We've gone through 2 years of a global pandemic, and no doubt a lot of changes in our personal lives. And it still seems like we're facing a continuous cascading series of crises in the world. The Eskwelabs Data Science Fellows have been navigating all of that while being in an immersive, community-led learning experience for the past 12 weeks. The Eskwelabs bootcamps are accelerated, part-time cohort-based online programs for aspiring data professionals who need accessible upskilling but want to get hands-on work-like experience and feel supported by peers and mentors. In this past cohort, we've also adjusted the curriculum to reflect timely opportunities for data science use cases, including a new project which focuses on visualizing election data. So in that way, the Data Science Fellowship is not only for those who want to enter the data science profession, but also for those who want to grow into leadership, both in business and society, by leveraging their data skills. The voices of our fellows will be adding diverse values and contribution to the future of how our digital economy will be built. And I know their presentations today will reflect that potential. And for our audiences, we hope the Demo Day presentation will spark your curiosity, will inspire you to learn data skills, and to continue to explore how our lives are being changed by tech. And we invite you to join us in sharing and celebrating the work of our fellows. Thank you.
Thank you, Angela, for that warm introduction. Thank you also for reminding us that the work we do right now here, that we will be presenting, is current, it's timely, it's relevant to the needs of our society today. So for those of you who are joining us for the first time, the Data Science Fellowship is a 12-week-long boot camp divided into 4 sprints with 1 capstone project at the end of the program. Tonight, we are here to celebrate and witness the hard work of our fellows as they present to you their capstone projects in this Demo Day showcase. I've heard a lot about Eskwelabs and about Demo Day, and I'm so glad that I'm finally here in this room sitting with all of you virtually to experience what reimagining the future with data looks like. Now, tonight's event will be divided into 2 main segments, with segment 1 happening from now until 8, where you will hear our first 2 groups who will be tackling counterfeit product detection and a product category recommender engine. We will be having a short intermission before we begin with our second segment, where our last 2 groups will be tackling projects about planet type classification dashboards, very interesting, and a healthy meals recommender engine. Now, that's something that I need in my life right now, a healthier meal. Now, without further ado, I'd like to introduce our special guest panel for this evening. We will be having 2 separate panels to take on the 2 segments that we will have. And so that's a recap of what's going to happen tonight. And now allow me to introduce our esteemed panelists who will be sharing their thoughts and asking the right questions to our awesome people from the Demo Day. Eric Tria is a business technologies lead of Shopee Philippines with several years of experience in software development. He earned his bachelor's degree in computer science from Ateneo de Manila University. He specializes in back-end development. Eric likes to play basketball and is an NBA analytics nerd. So basketball isn't just a sport. You can also put data and analyze data with it. Thank you so much for being here, Eric. Our second panelist is Irvin Liu. He's a business technologies professional at Shopee with several years of experience as a software developer in the banking, airline, and e-commerce sectors. He earned his master's degree in computer science from De La Salle University and had worked on several government-funded projects as the lead machine learning researcher. He specializes in the Internet of Things, data analysis and visualization, and process automation. In his free time, Irvin likes to tinker with electronics and play video games. I would love to play video games with you, Irvin. Thanks for being here tonight. Our third panelist for our second group, I'm sorry. Yeah, Finn is a passionate professional land surveyor or a geodetic engineer, as we call it here in the Philippines, with more than 10 years of experience in the field of geomatics, GIS, and remote sensing. He loves GNSS and has used it in open pit mines, geothermal fields, urban canyons, and vast waterways. He has also used it for both real-time kinematic and static observations with total stations, terrestrial laser scanners, ground penetrating radar, and unmanned aerial vehicles. When he is not doing land surveys, he dabbles with IT or IS, web mapping, open source, nawala for a while, open source, GIS, and some geospatial programming with R, MATLAB, or Python. These are his kinds of things. Right now, he's a senior lecturer on construction surveys and horizontal geodetic controls at the University of the Philippines, while also serving as the division chief of at the Philippine Space Agency's Space Data Mobilization and Applications Division. That is Serafin Meneses. And finally, to round up our panelists, we have the Customer Experience Manager for Chowking Philippines Delivery and Takeout Channels. He serves as a lecturer at the University of Santo Tomas and the University of the Philippines for Information Systems and Management. He graduated from the University of the Philippines, Mindanao, with a degree in agribusiness economics in 2015 and has a master's degree in applied business analytics from the University of Asia and the Pacific. That is Ken Libranza. And joining our panelists are our very own Caleb Tuddy and Bash Yumol. Tuddy is the co-founder and CTO at Eskwelabs, an edtech startup promoting social mobility through data upskilling. Caleb has over 10 years of full stack experience and was previously CTO of Nukon, an entrepreneur-first company which uses AI to analyze construction defects. Now, Caleb was the first data scientist hired at Westpac, a leading financial institution in New Zealand, and an award-winning data journalist in the New Zealand Herald. Ooh, a fellow journalist here. Caleb is passionate about the data for good movement and involved in projects using data for citizen and participation in democracy. And finally, we have Albert Bash Yumol. Bash is a senior data scientist at ING Netherlands, where he specializes in machine learning, natural language processing, and smart monitoring algorithms. He is also Eskwelabs' data science lead instructor. He is a self-proclaimed open sourcer and promotes open source technology and democratization of tech skills. He has over 10 years of experience with data science, both in academic research and industry applications. He is an advocate for using technology to promote social development and nationalism, and also teaches data science and its applications, focusing on human-centered design and data ethics. There you go, ladies and gentlemen and non-binaries. We have our esteemed panelists who, based on their background and experience, are in the right place right now, because they will be going over the presentations and going over the demos of our participants, and will give their feedback and questions later on. And so, with that, I'd like to introduce you to our first group of fellows for this evening. I am pleased now to introduce you to members of Capstone Group 1, Fred Baldo, Jeff Stu Enteria, DG Ann Pusing, to present Detect a Fake, Counterfeit Product Detection on E-commerce Platforms.
Can anyone give me a reaction if any of you had ever shopped online? Thank you. Can you also give me a reaction if any of you have experienced buying a seemingly good deal product only to find out later that it wasn't the product or brand or quality that you expected? Chances are you bought a counterfeit product. My name is Fred Baldo, and with me is DG and Stu, and we're going to discuss our capstone project, which we entitled Detect a Fake, Counterfeit Product Detection on E-commerce Platforms. Now, counterfeiting is defined as fraudulent imitation of a trusted brand or product. Counterfeiting remains to be one of the main problems not only in our country, but also globally, as it poses significant concerns such as introduction of dangerous products in the market, weakened regulations, diminish tax returns, and support unlawful activities such as money laundering and child labor. In fact, this problem is so serious that it is expected to reach $3 trillion by year 2022. Now, in the Philippines, we already have several laws and regulations such as Consumer Act of the Philippines, the Price Act, Standards Law, and Electronics Act that protect the consumers and address the problem of counterfeiting. However, there are still some problems in terms of monitoring and enforcement, particularly those involved in the e-commerce business. Some of the big e-commerce platforms also have introduced several policies to address counterfeiting problems. However, scammers are still able to find ways to bypass these rules and still list their products in their platforms. So our problem statement for this project is how we can detect counterfeit products on e-commerce platforms. Now, these are just some of the traditional ways we do to spot counterfeit products. We check on the price, the packaging, seller profiles such as unknown sellers, low ratings, and followers. We also look at product reviews to see if there are any indications about the product being a counterfeit. Our team believes that these features can be used to classify counterfeit products, and we want to automate this manual process. So, given the above background, our objectives for this project are to use machine learning to predict whether or not a product listing is authentic and determine how the features affect the decision-making of the model. The key stakeholders for this project include the government and e-commerce platform owners because this will help them intensify their prevention, monitoring, and enforcement efforts. The companies or owners of the brand names, trademarks, and intellectual property rights of the products being counterfeited. And lastly, the end users or consumers, especially my wife in scam. Now, they will have more efficient way to distinguish counterfeit products and hopefully would help in the fight against this counterfeiting problem.
Hi. So for our methodology, we went through 5 steps. First, we choose the e-commerce platform and decide on the target products. We used Selenium and Beautiful Soup to scrape the data from the website. Then we went through the data preparations before we build the model. We did unsupervised modeling to create labels for the data points, then proceed with the supervised to generalize the classification. After that, we evaluate the models using the accuracy metrics. We searched for the top e-commerce websites in the Philippines and we decided to go with Lazada. Its monthly traffic is at 25 million and it has a diverse selection of products and a large number of users. Then we look for target products. In the Philippines, the most popular product categories are electronics, fashion, and personal care. We also looked at the top counterfeited products and we found footwear, clothing, and electronics. For this project, we considered products under the categories shoes, clothing, electronics, and bags. So how do we collect our data? Well, we use dynamic web scraping using Selenium and Beautiful Soup. From lazada.com.ph, we input keywords. Then, from the search results, We scrape individual product links and come up with a dataset of product URLs. Then we loop through this dataset of URLs to get individual product details in each product page. And now we have our dataset. However, the search using keywords returns suggestions that includes products that are only similar to the specified product. This could be because they wanted to promote other brands or other products also. So we had to do some filtering of unrelated searches. After that, we did the data cleaning. We removed unnecessary characters, changed to correct data types, filled the nulls, and the likes. After filtering non-relevant searches, we were left with 70% of our original data set. This is the data set that we used for our models. Since our data doesn't have any counterfeit labels, we started with the supervised model. We did k-means and hierarchical clustering for each product category to come up with the counterfeit tags. So we were able to get two sets of tags from here. The k-means model was able to tag 48.5% of the products as counterfeit. Meanwhile, the hierarchical model tagged 43% of the products as counterfeit. Using the flagship stores or brands as our baseline for authentic products, we see that k-means tagged 88.9% of those products as authentic, while hierarchical tagged 97.6% of those products correctly. We also checked for the silhouette scores for each model. The silhouette score is the measure of the density and separation in each cluster. K-means had 70.8%, while hierarchical had 41.5%. So this means that even though hierarchical did better in tagging the authentics as authentic, the authentic clusters might have been too big that it also included counterfeit products. So from here, we see that k-means might be a better model. However, after further inspection, we see that there are still some data points that are not correctly classified. So to further improve the taggings, we also tried using manual verification to better establish ground truth for our supervised model. After this, the counterfeit to authentic ratio increased to 72 to 28.
Hello everyone. Now we'll be sharing the results of our analysis. So first, we've compared the price between counterfeit and authentic products, and we've seen that generally, authentic products are more expensive than counterfeit. We've also looked into the product rating, and it shows that for most products, authentic have higher rating. However, this is not the case for all. As an example, the counterfeit products of Nike Air 1 has higher rating than authentic ones. This is possible due to high selling price of authentic products. It is the same observation for the seller positive rating. Some buyers tend to be more practical and just go for the counterfeit because it's much cheaper. Looking into the common terms in the product labels, overrun, quality, and no brand are the common words that came out for the counterfeit products. To have a general classification of the counterfeit and authentic products, we also performed supervised modeling. At this point, we collected all 10 datasets from 3 product categories and used 3 models. One, logistic regression, second, random forest, and last is XGBoost. The results of this modeling will be shared on the next slide. Here are the results of the supervised modeling. We can easily say that random forest is the best model as it has the highest score across all metrics in identifying counterfeit products, with an accuracy score of 94%. Additionally, our team also checked the relationship between features that we have identified, and here are the insights. There is an association between highly discounted products and counterfeit. Second, there is very little association between product rating, seller rating to counterfeit. And last is, there is a slight positive relation between seller responsiveness, shipping on time, and for them getting a positive rating. In summary, detection of counterfeit product on e-commerce platform can be achieved through machine learning. As a matter of fact, we performed 2 machine learning, one supervised and second is unsupervised. Price, seller rating, and authentic certification are among the key indicators of authenticity. As for our next steps, we're planning to scale the data to include more product categories, not just the ones that we currently have. Second is we will explore other machine learning techniques that would enhance the data labeling process. And last is we are considering to integrate advanced machine learning techniques such as image recognition so that we can further enhance the classification of counterfeit products. Thank you. That's it for our group.
Thank you so much, Team Detect a Fake, for that presentation. Let's give Team Detect a Fake our digital applauses via Zoom. Zoom allows for that. Big, big congratulations. The team basically used machine learning to determine whether a product listing is a counterfeit or not, among others. Amazing. For our audience, please feel free to head on over to the Dory link, which has been sent in the chat. If you have any questions to the group, you can post your questions for the group in the Dory link. For now, I will be opening the floor to our panel of judges for their questions. Judges, please go ahead.
Yeah, hi guys. So first of all, cool presentation. I think the analysis part is really interesting, especially coming from e-commerce ourselves. It's pretty cool. So my question is only about your plan to scale. You mentioned, I guess, get a bigger data set, cover more categories. So we know that all platforms have their own security measures, like blocking for each site is different. And also, we know that Selenium can be pretty slow if scaled. So what are your plans for speeding up the process and also for overcoming the blocking and defense mechanisms of the platforms?
All right. As our time is going on, can we have any representative from the team to answer that question?
Hello, Sir Eric. Thank you so much for the question, and good evening, everyone. So, for the scaling, to be honest, that was the toughest part of our project. So I think I get the part where you're asking for that one. Probably on our next step, so we can probably look into continuing that path, or probably we can look into exploring a better process. Like probably there's an API that we can look into to make it faster. So actually that was our purpose here, to scale it so that we can attach more categories, not just what we currently have. So to be honest, that was the toughest part. We spent a lot of time in scraping the data, and I totally agree that there can be some form of enhancing it, so we can probably look into other process to enhance that the scraping of our data. Yep.
All right, sounds good. Sounds good.
Thank you for that, Stu. Thanks for the question, Eric. Do any of our other panelists have any questions, or would our teammates want to add something?
Yes, so sorry.
Go ahead.
Yes, just to add on that, Sir Eric, basically, one of the things that we also wanted to do is just for us to expand our domain knowledge in terms of identifying the counterfeit products. Because one of the problems that we encountered is that some of the products, it's very difficult to identify, especially for electronics, unless you really look at the specific details of those or components of those. So that is one of the things that we would like to do when we try to expand this project.
Great. Thanks for the supplement, Fred. Our other panelists may have their questions as well.
So far, no questions from my end, but I would like to commend the group for using various techniques to quantify their results, such as using silhouette score for clustering, then setting ground truths for comparison, and computing the confusion matrix, such as the accuracy, precision, and recall scores. Very good for the team.
I have a question, a comment first, guys. Yeah, I know the process. It took you so long to scrape the data, and I think in terms of scaling it, you can implement multiple stages of using Selenium, since it's pretty slow if you run it on one go. So you can like identify some parts of your projects to automate it first, or even totally replace Selenium with a faster version in JavaScript called Cypress. So you can also use Cypress to do your dynamic scraping. And I like your comment regarding the API. So if you can partner with this e-commerce companies like Shopee and Lazada, that would be like the best approach really to get data. So my question for you in terms of your recommendation and your analysis, that price, rating, and the other features that you identified to be contributing to your predictions, did you do any feature importance technique or any dimensionality reduction to pre-filter what fields would be relevant for your initial unsupervised modeling approach?
Thank you for that, Bash. Would anyone like to answer that from the group?
No. Hi, Bash. Actually, we tried, initially we had, after we tried to check the correlations between the features, we saw that around 6 features are, we can use around 6 features to, we can use around 6 features for our unsupervised model. And we also tried to use dimensionality reduction using PCA, but upon checking that, I think using the first two components, I think will just give us around 55% of the variance explained. And to get at least 80% of the variance explained, I will be dealing with at least 5 components, principal components. So we decided not to use PCA na rin because it's almost the same, as we will be dealing with many components also. So we decided to stay with the features that we already had using the correlations only. Thank you.
All right, thank you so much, TG. That answers my question. Good job. Just for the point of recommendation again from me, if you can collaborate with the business, like if there are any existing metrics that they already use to reduce those dimensions, like for example, if they have some metric to like multiply or do some linear combinations of the price with other metrics like discounts. So maybe you can use those metrics to combine them and reduce the dimensions of your features. Good job, guys. Congratulations. That's it for me.
Thank you, Bash.
Thank you, Bash.
I had maybe one question to maybe sort of jump in and ask. I saw you mentioned seller rating had some relationship with sort of whether something was genuine or counterfeit. And I wonder if you put your model into production and you started catching scammers that were selling counterfeit goods, would they change their behavior, try and create new accounts that have no ratings at all? What impact might that have on that as a feature? And what might you need to do over time to make sure that you keep some level of accuracy?
Thank you for that question, Caleb. Participants? Fellows?
Right. Thank you so much for that question, Caleb. So yeah, we understand that the model has to evolve as well, right? There can be instances where our current setup won't be enough, to detect if there would be changes in the behavior of either the buyers or the seller. So from our end, we can probably add it as our on the next step we're evolving. We would also be looking into evolving our model. So we're testing it, looking into other features that would be able to consider those new behaviors probably to I think you're gearing towards fraudulent activities, right? So it's something that we can also look into that. I think that's a requirement for all the models, that it has to be evolving, not just a stagnant one. So definitely we're looking to that. Thanks, Caleb.
There's another question from the Dory. Maybe I can answer this one. The question is, how many observations did you have? Well, we have around 6,000 data points. How did you how are you able to label the products as counterfeit or not? Well, we tried to do unsupervised machine learning models. We did k-means clustering and hierarchical clustering. And to further improve it, we did manual evaluation to see whether these clusters make sense. And we also tried to, to enhance it manually so we can better establish ground truths for our supervised model. For this one, we can also, I think we can also improve this by using other machine learning techniques, such as what do you call this? Such as soft clustering. Maybe for our recommendation, maybe we can also try soft clustering in the future so we can lessen the manual intervention that we did. We think we can use it to improve the labels, unlike the hard clustering. I think where one data point is assigned to one and only one cluster. In soft clustering, for each data points, the probability is assigned to the probability that a data point belongs to a cluster is assigned. So maybe those data points that the model is uncertain, maybe we can drop them off and use the remaining data points where we are confident, so we can improve them. We can improve our confidence with our labels also. We can filter them. We can filter out the data points where the model is having a hard time to classify. The next question is, did you also test the algorithm on a test validation set? Yes, of course, the unsupervised models. And I think our best model for that one is the the random forest model, where we had around 94% of accuracy. Yeah, that's it. Thank you for the one who asked the question.
There you have it. Thank you so much, DG. Thank you so much, DG. No more follow-up questions from our panel before we close off this group. None. And our fellows can breathe a huge sigh of relief because the defense is over. And you did a very great job. Congratulations to DG, to Stu, to Fred. And thank you so much to our panelists. Congratulations. Big hearts, big hearts. To those who sent over questions to our first group over at the Dory link, don't worry. If your questions were not answered, our fellows will be reading through your comments and answering those through the Dory link as well. Now, moving on, I would now like to introduce our second group of fellows with their project, Classify, Development of a Product Category Recommender Engine for Burkett. Please welcome Neil Ambrosio, John Benedict Bunkin, Mary Grace Lunar, and Maria Chris Zapanda.
Hello, everyone. We are Whoosh Solutions, and we are Ben, Grace, Neil, and me, Macris. We were commissioned by the company Burkett through Eskwelabs to develop a product category recommender engine for their request for quotations or RFQs. Let us introduce you to our client Burkett.ph, whose company name is a contraction of the words business and market. It is an e-procurement platform that links buyers to suppliers. For the project, we'll focus on the request for quotation or RFQs of buyers. This is the interface for that. Through the RFQ page, buyers get to initiate their search for suppliers. Burkett matches buyers to suppliers based on the information provided by the RFQs. Potential suppliers are then presented to buyers based on their match. At present, users manually input the product categories, which serves as one of the bases for suggesting suppliers. They have their own product categorization as their user inputs. Once they have the RFQ, they manually categorize the RFQ into the Google Product Taxonomy or GPT before matching them to suppliers. But this disconnect workflow or method is prone to errors and has delay in terms of connecting our buyers to suppliers. While GPT or Google Product Taxonomy, it recognizes that a particular set of products is suitable for a specific shopper with the aid of their taxonomy. Thereby, it arranges the product ads and thus results in smooth functioning. So our main objective is how we can automate and accurately categorize requests with minimum human intervention. So our project is to develop this recommender engine that suggests possible product categories to request for quotation made in the Burkett platform. These categories should match with the GPT. We start by exploring the data. We noted that the increase in RFQs coincided with the start of 2020 pandemic, which is around April or May. 2021 RFQ levels are already comparable to its pre-pandemic levels. We also did topic modeling of the RFQs. We generated 4 main topics: invitation to suppliers, asking for specific items with requested characteristics, and the focus was mainly on pandemic gears. The word cloud emphasizes the pandemic items requested through the RFQs.
Examining Burkett's data, we observed 2 main issues. First, the provided data by Burkett has no GPT label. And this is important to us since GPT label is the one that we are trying to predict. To fix this, we use Whoosh API to identify GPT categories of the given dataset. Here, we can see an example of categorization. Columns in black are the user's input, while column in yellow is the output of Whoosh API. Just to reiterate, we only use Whoosh API since our data is incomplete. And it is important to note that this method does not guarantee 100% accuracy, since output is dependent on the user's input. The second issue that we identified is the size of the dataset, which is relatively small to train our model. So, we augmented the dataset using PhilJeps, a procurement system of the Philippines. But we found out that PhilJeps data has a wider scope in a different format and has no GPT label. So we tried to filter the data to only those that are related to Burkett's.
So those were the steps we took for the data completion part of our data pipeline. Once we were able to complete our data set, we performed necessary steps in processing textual data, namely tokenization and removal of stop words. We also label and coded the general Google product taxonomy categories. With the structured data in place, we performed count vectorization to examine frequency of words as features to be used in the model, and TF-IDF transformer to add importance of words as again another feature that our model can use in classification. In other words, in the data processing and feature engineering stages, we wanted to make sure that our data was converted to numerical inputs by checking what words are associated with specific categories. And those inputs can be used by the model to make decisions. We then used 2 algorithms appropriate to classification of textual data, namely SVM and naive Bayes algorithm. We calculated accuracy metrics and selected the best model that classified quotations to the umbrella GPT categories. After the initial classification, we used NLP text similarities to check for specific GPT categories. A recommendation engine was put in place, which suggested top 3 specific GPT categories based on those inputs. Our training set is a combined data set from Burkett and PhilJeps, and comparing the accuracy scores generated by the naive Bayes model and the support vector machines model, it is very much apparent that the SVM classifier is the better choice. Our model is able to classify requests for quotation to the 19 umbrella Google product taxonomy classifications represented in the dataset with over 90% accuracy using SVM. We use the identified general category with the RFQ entry as inputs to a recommender engine, which suggests specific Google product taxonomies based on text similarity. The top 3 most similar were recommended as the specific categories under the Google product taxonomy. And to illustrate, after a buyer types the quotation details in the RFQ form of Burkett, our model will identify its general Google product taxonomy categorization. The general GPT category, together with the other RFQ details, will serve as inputs into our recommendation engine, which suggests specific GPT categories using text similarity measures. So Burkett doesn't have to manually tag the RFQs. Our recommender engine will do this for them, and specific categories can then be used as basis for suggesting suppliers.
So to give a recap, the product category recommender engine we used is the Whoosh API to generate the GPT product categorization that is used to train our model. And out of the models, the best model was the SVM, which was able to classify a product's umbrella category with over 90% accuracy. To evaluate how helpful the recommender engine is in improving user experience of processing quotations, it is important to monitor how long does it take for a user to process a quotation with and without the recommender engine and see if there are improvements in the processing time. And this can be done by monitoring changes in average time to process the RFQs. To further optimize the model, it is important to retrain the model with more entries and categories for a more holistic representation and accurate classification of all the GPT categories. We have the following recommendations to help our model smarter. So first, it would be best to have a data set that is correctly labeled with Google Product Taxonomy, as the data set we used to train was only generated by the Whoosh. So it would be better to have the Burkett dataset with the RFQs and their correct product taxonomy. Second is to use correct and validated dataset to retrain the model and improve its classification capacity. And finally, we would also like to recommend to consider adding fields where users can add additional attributes of the product for more specific order details and enhance the accuracy in generating categories. And having said those, we believe that our model can spur Burkett as it evolves into an even smarter platform where buyers and sellers can meet. Burkett has already built a structure and space where these two can meet, and with our solution, we hope they'll be able to meet as soon as they can. And with that, that was Classify, our RFQ category recommender engine for Burkett. We thank you.
All right, that was Team Classify. Let's give them a digital Zoom applause. Thank you so much, Team Classify, for that presentation on a recommender engine for product categorization using natural language processing, among others. Really, really awesome work. Again, for our audience, as mentioned in the chat, please feel free to head on over to the Dory link to send in your inquiries for the group, and we will answer this during the Q&A or reply directly to them after. We would also like to acknowledge the presence of Burkett founders themselves, Jeff Turla and Herbert Baktong, and the other Burkett team members who are here tonight. Congratulations, Burkett. We look forward to seeing this project continue beyond the Data Science Fellowship. Thanks for being here tonight. Now, it's time for the second round of Q&As for our fellows. Judges, you can now take the spotlight and ask your questions for our Team Classify.
Okay, I can begin, I guess.
Go ahead, Bash.
Good job, guys. Your solutions are very clear in terms of like a business standpoint. I wanted to focus on your metrics calculation. So you mentioned that you have a model performing 90% accuracy, right? How do you know that this is correct? Did you try, how many experiments did you do to calculate this 90%? Is it just one pass? And then how do you plan to improve this? If this is high as an accuracy, how do you account for overfitting?
Right. I guess I will answer on behalf of our team first. So thank you for that, Bash. In terms of how many passes, in our model or in our modeling process, we actually did so the naive-based model and the SVM model were the two algorithms that we ran in our data set. The first one was 56%, the other one, or SVM, was 90%. We stuck with the 90% accuracy because, it was, for us, it was already good, in terms of accuracy in classification. We were able to generate this, since we saw that with the initial GPT categorization that was generated through Whoosh, our SVM models was able to predict using the text data the similar GPT categorization that was implemented by, or that was identified by the Whoosh API. So I guess those were our basis really to or how we were able to identify that our model was able to classify 90% of the time. Maybe my group mates would be able to add more inputs to this.
So just to add as a recommendation, normally when we're doing these types of like validation, you don't only do one pass, you apply some form of like k-folding or like cross-validation to have and even to circumvent overfitting eventually. So you can try exploring k-folding and cross-validation for that matter. And then for my other question, how can you improve 90% if your clients are not yet satisfied with that performance?
Right. I guess for us, really, our focus was initially was to find an ML approach to it. The data that we had or that was turned over to us was something that was first, it was small. It was a very small data set, but we really focused first on building that data set. And then in terms of improving the model, definitely if we had more data, since right now Burkett is still in its initial stages, so it has a lot of potential, so it's still getting more and more requests for quotation. Maybe eventually if we had more data that we can work it that are really requests for quotation within the Burkett platform, then those are again more inputs that we can use to improve our data. And then we can also explore more models or other algorithms that can that has higher accuracy rates.
Yeah, good. Yeah, but that's the problem with Philippines data, right? We can't really focus and complain about data quality because that's a given curse. I would also recommend, if you want to increase it, to look at your NLP similarity metric. I think I would assume that you're using Spacey. So the algorithm that is being used is cosine similarity, I think. So you can, there's a new field in data science emerging called distance learning. So there are like a bunch of algorithms that are published like every day that would like help you increase that. So look at the term distance learning. It will help you augment the similarity of the tags that you're trying to annotate. Yeah, that's it from me. Good job,
Thank
guys.
you so much, Matt. Thank you.
Thank you, Bash, for those recommendations and questions. Do any of our judges have questions themselves for Team Classify? Or comments, suggestions?
Just one question from my end.
Go ahead, Irvin.
So I'm curious to learn about the train test split that the team used. Since, as mentioned, you're working with limited data. And then as Bash mentioned, NLP projects tend to have overfitting problems, especially with limited data. You might be using the same data that was used to train the model to test it, hence the high accuracy scores. Yeah.
Right. Initially, that's what we performed. The same in terms of train test split. We also performed, just testing the model on the Burkett dataset. Since our model is a combined dataset of the requests for quotation from the PhilJEPS data, so it's a totally different dataset, but it also contains requests. So we use the model to just categorize solely the ones that are on the requests for quotation within Burkett. And our accuracy metrics went down to 85%. So definitely it's an issue that we still need to address, but I guess our contributions for Burkett, given that we still have a small data set right now, our model and I think the data pipeline that we're able to establish is something that they can use later on when they implement this in their platform.
So another suggestion would be if you could actually show us earlier the other metrics, such as the precision and recall, especially the recall, so that we can get a better understanding on how the model performed. Yeah, that's it.
Thank you.
Yeah, so for me, first of all, good job, guys. It's really, really cool presentation, and I think the analysis was presented really well. So my question is more of like in terms of deploying the model to production. Let's say Burkett makes use of this in their platform, and you guys will be expecting like more data to come in, more requests. So what issues are you guys anticipating would come up if this scales up, and like what are your plans for handling those issues?
Hello, thank you for okay. Sorry, can everybody hear me? Yes, sir. Thank you. I think one of the issues that we'll encounter in terms of industrialization or productionization is the coverage of the categories, because we noticed that most of the core requests that we've covered is on the pandemic year, since we've covered from 2020 to early 2021 data. So once Burkett have new questions for a different set of categories, we definitely need to retrain the model to be able to catch those RFQs. Thank you.
It sounds good. Sounds good. Yep.
Right. I think that's it for Eric. Caleb, did you have any questions or recommendations to the group?
Yeah, I am quite interested, I guess, because with NLP projects that have taxonomies that have like multiple levels, it can be difficult when you get to something that is more specific. Did you run into that? And what strategies would you have around looking at getting more specific in terms of like a deeper category level?
Right. I think that was the biggest issue that we had, since the Google product taxonomy is actually around 6,000 categories, right? So it was really, and our data set was comprised of only, 2,000 requests. So it's definitely an imbalance in terms of, the number of cases vis-a-vis the number of categories that we're trying to predict. So our solution really was to first, let's get into the more general categories first, which is more limited, which is I think around 20 to 30 categories only. So that was our strategy. Let's classify it first in its more general categorization, and then using that as an additional input into our, in our categorization, we can now suggest more specific categories. And this time we used NLP text similarity for those more specific GPT categories.
That fulfilled it, Caleb? Right. Do you have any other questions or comments from our panelists for Team Classify? There's a question here. Allow me to read it. How does your model improve the user experience with Burkett? And how does this compare to competing platforms? Anyone from the group can answer this.
Or maybe I can take this one, and then my group mates can just supplement with their responses. In terms of user experience, I guess really one of the problems right now is the manual categorization that's being implemented at the back end. Since Briquette still has to manually categorize the Google product taxonomy to match it with suppliers, that's a big delay in providing that recommendation for this, that supplier recommendation for buyers. So if our model were to be implemented, then it really minimizes that time. Burkett doesn't have to scour through the thousands of categories and match it with the a product category that's just so they can recommend a supplier. So in that end, or in that aspect of user experience, that's really where our recommendation engine can really help. Maybe my group mates would be able to expound more.
Yeah, so we haven't really evaluated if or monitored or measured if how much has our Burkett category recommender engine has improved the user experience, because as like what we said with our next steps in the our recommendation, we really need to monitor in the future, how long does it take for a user to process a quotation with the recommender engine and without, to see if there are any improvements in the user experience and the processing time.
And
All right. Oh, go ahead, Macris.
sorry, if I may add, aside from the user experience, we're thinking that this platform can be a jump start. Like for example, since they're manually sort of connecting the RFQs to the suppliers, like emailing them one by one. Once they have generated the categories, they can connect it to a CRM platform so that they can automatically email to the suppliers the RFQ information, and thus minimizing the human intervention and the delay time in terms of connecting to buyers and suppliers.
Thank you so much, Macris. And I think that's time's up for our question and answer portion. Thank you so much to Team Classify. Let's give them our digital applauses. Tapos na kayo. Congrats. And of course, thank you so much to our first group of panelists who have, if not only asked questions, but also gave their own recommendations to make the project, capstone project, even better and more polished. Thank you also so much for that. Thank you again to those who sent over questions. We will go over them through the Dory link. Those were our first two capstone projects. The first one is detecting for counterfeit posting or not. And the second one reimagines a recommendation engine for product categorization. I think everybody did a great job in answering those questions, those difficult questions. I think everybody deserves a big round of applause. Amazing data stuff. Data stuff. I'm just so flabbergasted by the things that I see and hear from these fellows. Awesome job. All right, before we move on to our second segment and last two capstone groups, we will be having a short break. So take a quick break and we'll see you back here at around 8:06, 8:05. See you. All right, we're back. We're back. We're back. I hope you had your water break, screen break, hygiene break, because we are in for next set of capstone projects. And this is definitely exciting because the next two capstone projects are going to be super interesting for those whose hearts jump at the thought of space or planets or maybe zodiac signs. Just kidding, that's different. You're in for a treat because this next capstone project is going to cover something about planet type classification. And the fourth capstone project that will be presented tonight is something about health. I think that's very relevant. And sa oras ng COVID-19 and times like this, ang ating health is our puhunan. So we are excited to see that second project being presented later on. Now, this next one is going to be very exciting because he is our only fellow doing an individual project tonight. Grabe, ito yung batchmate natin sa high school who's like super, yeah, game on. I'm here for this. He's the one and the only. Please give a warm welcome to Mr. Paulo Dano with his project Cosmo, a test object of interest, disposition, and planet type classification dashboard. Here we go.
Greetings, fellow space travelers. I am Paulo Dano, here to present Cosmo, a test object of interest, disposition, and planet type classification dashboard. For our space journey tonight, we will talk about NASA's Exoplanet Exploration Program and the current problem that they have. From there, we will look into how I intend to solve this problem, and by the end, give you a demo of Cosmo. So let's get started with the project. Let's start with some terms. An exoplanet, by definition, is simply a planet beyond our solar system. They can be categorized into two kinds of planets and further categorizing them into 4 planet types. So they are either terrestrial, super-Earths, gas giants, or Neptune-like. Terrestrial and super-Earths, which are rocky planets, with super-Earths being the bigger one among the two. And gas giants and Neptune-like, which are gaseous planets, with Neptunians having rocky centers instead. To get data on exoplanets, the NASA Exoplanet Exploration Program launched the Kepler Space Telescope and the Transisting Exoplanet Survey Satellite, or also known as TESS, which have each found 2,057 and 3,494 exoplanet candidates respectively as of now. So far, there have been 2,709 exoplanets that have been confirmed and classified from Kepler's data alone. But how many has been confirmed and classified among the test candidates? Only 197 exoplanets. We can observe that the process is quite slow, given that there are a bazillion stars in the galaxy and possibly even a greater number of planets in the universe. It would take until the end of the universe before we actually get to finish the mission. Another problem shows itself when we talk about the resource cost of confirming an exoplanet's existence and planet type. Currently, a method called spectroscopy is used to measure the compounds found within a planet's atmosphere. However, spectroscopy is resource heavy and time dependent, meaning that we could get inaccurate measurements of the planet's atmosphere. So then my project aims to do the following. I want to solve NASA's hurdle of taking a census and characterizing exoplanets by creating a cost-efficient classification pipeline, meaning that I will only use test data that's available that produces quick and accurate predictions of the disposition and planet type. Now let's look into the methods on how I intend to solve this problem. But first, let's look into NASA's current pipeline in a high-level perspective. Currently, they get data from tests using sensors that measure a star's brightness. They would then be stored in a database, which will then be examined using their own classifier called VESPA. VESPA would detect whether they are false positives, known planets, or candidate planets. They would be stored in the test candidates database, which is stored in the NASA Exoplanet Archive. As we can see here, here is a sample of the database. We can see that the data is tabulated cleanly, and through the website, we can download CSV files for our own use. Next, we needed to get labels for the planet types. This method required me to use Selenium to scrape the NASA exoplanet catalog and get the planet types of the exoplanets with known names. This filtered out the test exoplanets since majority of them has not been given a name yet. So, after collecting the data was fed into this pipeline. In this pipeline, the dataset must first be combined, and then we do some balancing. Afterwards, we create some features using known formulas in physics and then filter out the features by relying on their variance inflation factor. Once a data set has been done, we feed them into COS and MO to create the models. In the end, when we want to classify something, we would first get input from COS and then determine whether it is a false positive or not. If it is an exoplanet, it would pass the data into MO, and then MO would determine the planet type associated with the exoplanet. And then we get the result, which is the disposition and the exoplanet type. Now let's look into my findings for this data. First question, what are the best set of features that we can actually use for classification? And to do that, we needed to do some cleaning first. We needed to remove some outliers that are present in the data. We would check if there are any outliers and decide to remove them or not. In this case, the outliers are present from here to here. As we can see here, majority of the data seems to lie from before this line. So then we remove those and get this. Next, for stellar effective temperature, it's easier, such that these two are the outliers, and then this one is the outlier. From there, we get the distribution. Next, we have the stellar log G, which includes outliers here, and from there, we remove that outliers. And lastly, we have the stellar sun radius, which includes outliers that could be present from here to here, and from there, we remove the outliers. Now we do some feature engineering. The features were made using well-known formulae like Newton's law of gravitation and the volume of a sphere. We also removed the features that were used to create these engineered features, such as star equilibrium temperature, planet Earth radius, etc. A sample calculation of getting the star's mass using Newton's law is shown here. Next question, before we do any classification using some machine learning, how can we actually tell which is which? In terms of the disposition, I only chose it to either be false positive or an exoplanet, as we are trying to filter out candidates. In the first plot we have here, the most defining features seem to be the orbital period, the transit depth, and the star's mass. As we can see, false positives tend to have a smaller star mass and a bigger average transit depth and a bigger average orbital period. In terms of the planet type, we can see a strong disparity between each type. For example, it seems that on average, the Neptunian planets tend to have a longer orbital period as compared to the other planet types. And we can see here, we can see how the Neptunian planets are also bigger in the transit duration as compared to the other planet types. Now, how well does our pipeline distinguish among false positives and exoplanets and the 4 different planet types? So given those features, what classifier performed the best? In terms of the disposition, without feature engineering, these are the accuracies of the different classifiers. The best one is the CatBoost classifier with a median of 79.50%. When we input our feature engineered dataset, we can see the drastic change. Our best classifier has a median of 89.96%, which is a 10% increase in accuracy. In terms of planet types, without feature engineering, we can see a weird result. It seems like the other models on the left did okay, but then the tree-based classifiers always got it 100% of the time. This is a red flag since they may be overfit. To remedy this, we have to do some balancing using oversampling. When we input our feature engineering class dataset, we can see that all of the models improve drastically. The tree-based models are no longer overfit, and the highest base accuracy based on the K-neighbors classifier is shown here. We can see that the feature engineering increased the accuracy by around 7% on the K-neighbors classifier. For this case, the best performing classifier is the XGP classifier. Now, let's take a look at Cosmo. So here's a basic dashboard for Cosmo. Here, the user inputs all of the required values that we need, such as the planet Earth radius, the orbital period, etc. And once we click submit, we can get a prediction of all of these characteristics. In here, we can see the results. So for this test object of interest, we can see that this is possibly an exoplanet, and then the planet could be a Neptune-like. And as we can see here, we can see the probabilities of the exoplanet and of course the planet type. We can also compare it and see how it fares compared to the entire corpus of data. For example, we have here the planet Earth equilibrium temperature, which seems to be that our object of interest is about the same as most planets. Now, this was an interesting study to conduct, but what do these things actually imply and where can we go with it? Because of Cosmo, We are able to characterize and take a census of planetary systems easier than before. We are also able to get a more expanded characterization of a planet and summarize it. We are able to know if something is a gas giant or a super Earth or even a terrestrial planet and expand our characterization easily without the need for a resource-heavy and time-dependent method. Lastly, the results in Cosmo could help accelerate further studies in other fields, such as astrobiology, chemistry, and material science. We could increase our knowledge of the universe and learn more about different things such as life, materials, and even physical properties outside the bounds of planet Earth. Moving forward, Cosmo would help FESPA to be more accurate, like an ensemble method in its integration. Other than that, more advanced features that I may have missed that only domain experts could find or develop could increase the performance of Cosmo in the future. Lastly, due to the lack of data, it was quite hard to incorporate the test discoveries. However, if we have more test data in the future, we could incorporate them and even further improve the performance of Cosmo. That's it for me. Thank you for listening and see you all in the stars.
Love it. The star is right here with us, Mr. Paulo Dano. Thank you so much for that out of this world presentation. Alam mo, it was very interesting to see physics, the real life application of things we learn in physics, yung gravitational force na nakita natin sa pipeline mo. Thank you so much for that. Very interesting. Again, you know the drill, everyone. Please feel free to head on over to the Dory link to send in your inquiries for the group, and we will answer this for Paulo rather, and we will answer this during the Q&A or reply directly to them after. My first question is coming from myself. Paulo, what do you eat for breakfast, lunch, dinner? Because I want it. I'm just kidding. It's time for Q&A with our panel of judges. We have with us again Caleb and Bash, and of course joining us for this panel is also nawala. Is also Finn and Ken. All right, take it away, judges. Who wants? Okay, go ahead, Bash.
Okay. Hey, Paolo, good job on pulling this off. Amazing use of physics to translate it to more like digestible stories. I'm also coming from an instrumentation physics background, so I'm familiar with Raman spectroscopy, how we use those signals to pre-classify exoplanets. My question is that Miss Universe question. What does it tell about our universe in terms of like your results? How many planets are in general Earth-based terrestrial planets or gas giants or Neptune-like? What does it tell about the distribution of those categories?
Okay, I'll be honest. That's actually quite hard to tell given the data that I was presented with. So again, the data that I had was only collected using the transit method. And the transit method actually uses shadows. And because of that, it's actually hard to detect those planets that are farther from the sun because they would have larger orbital periods. And suppose that they transited once, then it would actually be hard to see when they would transit next again so that we could actually observe them. So, but based on the data itself, like majority of the planets seem to be quite, most of them are gaseous. A lot of them have are either Neptune-like or gas giants. And there's also more super Earths than we know than terrestrials. And but that's only in the data that I found itself. Like the data itself has, say, orbital periods which are quite low, and that's actually quite a bad generalization for the universe since it's quite limited in that aspect.
Yeah. So do planets have rigid categorization then? So can we say based from the algorithms that you consider that there are intersections between category types?
Yes, I believe so. For example, the terrestrial planets, the super Earths and the terrestrial planets, they're both rocky. The super Earths are just larger, and
All right, good. Last maybe question or comment from me. So you mentioned from the distributions that you showed earlier that you did some outlier analytics to remove extreme values. So how does that work? So what type of outlier analytics did you use?
Um, I didn't I didn't say anything about an outlier analytics. It was more of an eyeball thing. So I looked at those that were quite extreme and didn't actually fit the data in itself. So what I actually did was I used Koglomerov Smirnov to actually test the data itself, and based on those I saw whether they were close to normal, and and if they were close to normal, perhaps just some outliers were disturbing that distribution.
So from your Kolmogorov-Smirnov test, the p-value is greater than 0.05 for all of your distributions?
Yes.
Okay,
yeah.
so you're assuming that you are following a normal distribution, right? But I think there are still merits into like quantifying the characteristics of those outliers. Maybe they are new classifications on their own, so that might be a point of interest as well. Aside from Kolmogorov-Smirnov test, you can also consider basic statistics like looking at quartiles, right? Interquartile range, for example, similar to like a box plot. Remember, like the small dots in your box plot, you can consider them as possible outliers. And aside from just plotting verbosely those histograms, you can apply some transformation mechanisms to clearly find the patterns, because a lot of these patterns are not only time-based. Sometimes you can get merit from applying frequentist like approach, like looking at or transforming your data using Laplace transformation or even Fourier transformation. So that might help you better feature engineer your data set before you use your clustering algorithms. But so far, good job.
Thank
I
you.
like the dashboard. Yeah.
Thank you.
Thank you for that, Bash. We'd now like to get some questions from Finn or Ken or Caleb. Go ahead, please.
Hello, good evening. Good evening,
Go
Paolo.
ahead, Finn.
I actually like your presentation, especially from a space scientist like myself. It's good to see the younger generation also interested in this stuff. What actually caught my attention was your use of Newton's gravitational force, wherein you mentioned that you canceled the density of the sun or of the star. But why did you do that? What's the reason behind that cancellation?
I don't think I canceled the density of the star. What I did indeed cancel was the mass of the crust. So yeah. So the thing that I was presented with was the surface gravity of the star as measured, and for me to get that, I assumed a particle on the sun's surface that is negligible compared to the mass of the star, and from there I use Newton's gravitational constant, assuming that it is a perfect square. Yeah, it would be r. Then yeah, I'd get the gravity from that.
Okay.
Yeah, the mass.
Usually, when we do that, actually, when we're comparing the gravitational pull between two celestial bodies, it is the mass of the planet that we assume to be negligible, because the star, if you can imagine, the star is so huge and so dense that the tendency is the mass of the planet that's revolving around it is very small compared to it. My other observation was on time. Actually, the scale of time in astronomy is different from how we perceive time here. For example, the bending of light, when it reaches here, the explosion of the star happened many years ago. For example, they recently discovered a black hole, and apparently the black hole imploded on itself during the time of the American Civil War. So the way that we should look at time when detecting planets is quite different when we use time here on Earth. So that's why I think maybe in the future you can use the theory of relativity in your other features, and then of course Keplerian motion, because the suns and the planets tend to wobble around the center of mass of their the galaxy that they're in, and these are not captured using spectroscopy. And I think the last major parameter that astronomers use is Doppler shift in the electromagnetic spectrum, or in,
Shift.
yeah, when the stars move further, the light looks red. When it goes near, it will look like bluish. So those things, especially that you're only using, I think you mentioned 197 confirmed cases to classify the rest of the around 5,000 plus probable exoplanets, right? So I think these additional parameters will help in Cosmo.
Thank you. So yeah, I don't know if I can add, but yeah, thank you for all those comments. And yeah, those were quite useful, especially applying time to the features itself. So yeah, I don't have knowledge about the theory of general relativity by Einstein, but I could read up on it and try to create more features on it. And in terms of the limitations of the data itself, it was actually quite hard to get the mass of the planet, because yeah, it was something that I actually worked an entire weekend trying to calculate, and the data didn't provide itself. And also, I believe what you were talking about with the wobbling star was something like the radial velocity method. So yeah, if I had data on that, I would be able to get the mass of the planet, and that would be a very, very big feature for me. Yeah.
Thank you so much, Finn and Paolo. Yes,
Yeah,
Finn.
good job, and I'm looking forward to working with you in the agency in the very near future.
Thank you for.
We have a job hiring right in front of us. I only know about planets Venus and Earth. No, I'm kidding. Caleb, do you have any questions, suggestions, concerns you'd like to give to Paolo?
So, in the light of such brilliant people like Sifin and the other panelists, I'm going to ask a really dumb question, maybe. That with just maybe that orbital period, like the length of time, and I think we've heard that maybe there's a lot of more complex things going on, but is that length of time and maybe the size of the star that it's orbiting enough to give you a good picture of the kind of planet it is? Just those things, or is it a lot more complex and it requires a lot of other factors? Yeah, I'm interested in that.
Okay. I didn't give this out in the presentation, but I found actually something quite interesting that I feel like I don't know if there's a study on it yet, but I researched on how the star actually affects the planet type. So as I've found based on the data, those stars that are smaller and tend to radiate less heat, yeah, they tend to create more gaseous planets near to them, and those that are bigger and higher in heat, yeah, they tend to create more terrestrial planets near them. So yeah, that was quite an interesting found. And yeah, I don't know if that answers the question directly, but yeah, that's something that could be considered.
Cool, thank you.
Thank you.
Right, I think that's it for our time for our Q&A. Can we give our digital applauses to the one, the only Paolo Dano for that Cosmo incredible out of this world presentation. I would like to invite you to tell me more about the world beyond planet Earth, because I'm sure I will learn a lot from you. Thank you so much, Paolo, and thank you so much to our panelists for that. Again, if you have any questions for our fellows, you can head on over to our Dory link to ask those questions. And for those na may mga tanong na hindi ko po na itanong during our Q&A, please just send them over to the Dory link so that our data science fellows can go over them and answer them when they can. All right, we are now down to our last capstone group of the night. Ayan, ang bilis pala ng oras, no? Please give A warm welcome to our final capstone group, Francis Ray Quintana, Kuy Dong Riman, Basti Vergara with Go Healthy, a healthier meals recommender system.
Hey everyone, thanks for having us here. I'm Basti, and together with me right now are Kuy and Francis, and we are Yumtech, and we present to you Go Healthy, a healthier meals recommender system. Now, are you someone who has a growing concern on your own physical health? Or maybe you're someone who wants to have proper nutrition but don't really know where to look for information? Well, ever since the pandemic, there has been a growing concern. As more Filipinos face isolation, it adds up to poor nutrition. Particularly here in the Philippines, the major cause of sickness and death are non-communicable diseases like stroke, peptic ulcer disease, diabetes, and various types of cancer. And together with the lack of information, Filipinos tend to choose just whatever is available within their household. And looking at this current situation, the Philippines has shown limited progress towards achieving the NCD targets, and thus obesity rates are rising as poor nutrition persists. And so the cost of treating diseases and the suffering of the patients would have been unnecessary if we were able to prevent them from happening in the first place. So really, the question is why? What is it about our meals that has such an impact on our health? Well, some meals are not necessary for a healthy diet and are too high in saturated fat, sugar, and salt. And so some studies suggest that limiting the intake of these ingredients could reduce the risk of developing NCDs. In addition, a recent survey showed that 89% of Filipinos believe that they needed to change their diet during the pandemic. And as such, there is a need for a smart strategy to help Filipinos create healthier meal plans. And thus, we developed Go Healthy, a recommender system for healthy meals that observes proper amounts of sugar, salt, and fat based on the user's preferred ingredients. Now let's dive more deeper into how we made Go Healthy.
We've scraped several sites for the recipe data. We didn't settle with only one data set, as they might contain label data that the others would lack. And least labels of concern for us were the cuisine and the course. After the EDA, we computed nutritional thresholds per recipe on the recipe's ingredients list. And then the entire data set then went through natural language processing. And then the data was now ready to be trained. And after training, we had 2 available classifier models that were ready for the recommender engine. Let's take a glance at the data sets used. So RecipeDB was utilized for training the cuisine classifier model, while Yumly, even if it's fewer with 15,000 recipes, was utilized to train the course classifier model. FNRI's 125 recipes were also included for local representation. And you can see there that we have a nutrient data pulled from PhilFCT. This was used to compute the nutrient threshold labels, which was attached per recipe. Now, these labels were computed from FNRI's Philippine Dietary Reference Intake. In summary, a nutrient threshold label of 1 would mean that you'd have no problem having that dish 3 times in a single day. In contrast, you'd be advised to only have a single serving of a dish in a day if it had a nutrient threshold label of 3. So these nutrient threshold labels go for the major nutrients or of concern, such as salt, sugar, and fat. So for our cuisine classifier, first, through text vectorization, the ingredients became these features, and their numerical value depended on their frequency in the recipes, as well as their connection with other ingredients. And then principal component analysis was done to weed out the ingredients which were not really helpful in identifying recipes while maintaining a 95% variation all throughout. And then using the clean data, we were able to have a support vector classifier model, which used a radial basis function kernel, and the output cuisine classifier could then classify or predict what kind of cuisine your list of ingredients as input would be.
So for the course classifier, we converted the ingredients into one hot representation. Then to ensure that all vectors have the same length, we applied pad sequences. Then we trained an LSTM model for 1,000 number of epochs. And then we have our recipe course classifier. So our LSTM model has about 3 layers. From the input, we have the embedding layer with an input dimensions of 131 and output dimensions of 64. Then we added an LSTM layer with 100 neurons. We also applied a dropout rate of 0.25. And finally, we have our dense layer. We used softmax as our activation function and a final output of 5 categories. We also used parameters such as Adam optimizer, as well as categorical accuracy and cross entropy for the metrics and loss, an epochs of 1000, and a batch size of 64. So we now move on to our results. So for our EDA, this is from the recipe DB dataset. The figure shows that the largest number of recipes come from Europe, which accounts for 39.6%, followed by North America, Asia, South America, Oceania, and Africa. So from the YUMLY dataset, because the recipe DB dataset did not have course labels, we selected 5 classes to represent the courses from our recipes. Then we used these to train our course classifier to label the rest of our data. For the modeling, we have an SVC model for the cuisine classifier and an LSTM model for the course classifier. Our SVC model got an F1 score of 55.77%, while the LSTM model, we got an accuracy of 93.72% and a loss of around 20%. So now we move on to our recommender engine. So the recommender works by taking in the user's input of ingredients and filters. Then we have our models to classify the set of ingredients, and we also applied ingredient matching. This was followed by cosine distance calculations. Then the recommender applies threshold and filters to the recipes and generate the recommendations back to the user. So here we show the user interface of our Streamlit app. First, you input the ingredients to the text box, and you could also select the recipe cuisine and course to filter out the results. The recommender will then give you a list of suggested recipes. Then on the right side, the user can sort recipes according to the components' class labels. So for this one, we sort the results based on the highest fiber content.
So for the conclusion, Go Healthy can offer healthier meal alternatives to lessen or avoid the consumption of fried and processed foods, canned goods, and fast food meals. Users can also explore recipes while keeping sugar, salt, and fat levels within acceptable limits, as well as explore high fiber recipes essential for a healthy diet. Now for our recommendations, we recommend to acquire more labeled data to train and improve the current models, and include Filipino common names as well of ingredients in the vocabulary, as well as explore flavor-based recommendations. We also suggest to deploy the app in conjunction with other campaigns or projects to garner sufficient user feedback in order to test the success of our engine. Lastly, we would also partner up with SMEs that offer lutong bahay recipes and meal subscription plans to offer that personal experience to our users. Now for our limitations, Go Healthy can only provide healthier meal alternatives for users to explore based on sugar, sodium, fat, and fiber. The values for these components are only estimates and may not represent the actual values. It's also not suitable for people with allergies or other comorbidities. And lastly, it can't provide a diet plan for people suffering from malnourishment, being underweight or overweight, or obesity. And with that, we are YumTech. And if you have any questions, send us a chat. Thank you.
Awesome, awesome. That was Team Go Healthy. That capstone project made me a little bit hungry. Thank you so much, Francis, Kuidong, and Basti for that wonderful presentation, and to the rest of our fellows for their amazing capstone projects. Let's give all of our fellows a virtual round of applause for completing the Data Science Fellowship Cohort Batch 8 and for presenting their awesome capstone projects. Again, you know the drill. Please feel free to head on over to the Dory link to send in your inquiries for the group, and we will answer them during the Q&A or reply directly to them after. Now it's time for the Q&A segment with our panel of judges. Who would like to be the first? Ken, would you like to give your inputs for this group?
Hey Val, thank you. First and foremost, for the first 3 groups, very good in terms of the presentation. For this one, I really do appreciate how detailed your presentation was. Great job for Go Healthy. I was watching your video ahead of time, and it was really so detailed in terms of what you really want to accomplish in terms of your results. My question is more of like a business impact for your project, and more on relating it to like a need for business. how do you actually address a specific health requirement for people? Because when you look at a health, it's not really just you can recommend specific food component for specific people. It's very dependent on, for example, uh, where they are located, how much do they weigh, their age. There's a lot of component to be considered here. So there's a lot of issue in data ethics in terms of using of health data and food data. So how do you address that in terms of your model and your recommendations?
Yeah, thanks for that question, Ken. Yeah, definitely those are some important points that we need to consider with our model. But that's why one of our limitations is really our engine is really just a meal alternative for users to explore, and it's not really something that can replace a a full meal plan. Um, yeah, if there's something else that my groupmate can add from that.
So maybe for the uh, in terms of what you mentioned about the different uh, parameters that may um, contribute to like providing recommendations to the users, like the weight. Yeah, for that one, our recommender could not possibly provide a specific diet for a no, a person. So um, for that one, we could consult a professional like a nutritionist maybe, and yeah, to provide like safe recommendations to the to the end users. And for the data collection, yeah, we we also would like to apply, yeah, some data ethics then, because yeah, maybe to have a, what they call this, like to not include the private information of the different people, so we might take that data in excluding the private information for the users then.
Yeah, actually, I was looking more into how this will be applied for like example in conjunction with like there's a lot of already food recommender apps that are available out there, and then or even like health apps that are available. Like how would you be able to like combine that in terms of that context in terms of the context in providing better recommendation, because I think what the algorithm teaches you is really more on classifying food based on this 1, 2, 3, 4 level, and that's something that's much easier in terms of customer experience, translating that compared to like saying, okay, this food has 250 grams of fat, or this food is equivalent to 250 kilocalories. That's a little bit difficult in translating it to like customer experience or user experience. So your approach in terms of labeling it from 0 to 4 was actually something that is very gonna be very appreciated in terms of user experience. So I think that's one of the strengths of the group in providing that one and creating classification for your products, for your food. And I agree, for example, in creating this for Filipinos. But if I may suggest, there's actually two ways in looking into this, or two approach. And the first approach is really based on like customer approach, like what other apps are using, getting the profile of the people. For example, my age is 22. I'm a little bit healthy. I do health activities 1 times a week. These are the activities that I do. Then you can provide like a recommender engine for that specific group. So that's based on customer segment. A second one is really more on availability approach. Like for example, what products or food are they is available for these people? Like are they more on the like a vegetable preference? Are they more on the are they more of like a protein based people? Because there's different approach towards people. So there's really I mean, in a customer perspective, as a user, potential user for your recommender engine, there's really two approaches for this. It's either you approach it on a profile, like a person's perspective, or a second one is on availability and what's available for that specific people, like in terms of the food that they actually consume in a day. I think that's it. Mine is really more an alignment based on like requirement for personalization, which is which what I said earlier, user wise and customer experience wise, this is a bit easier compared to like telling people like you need to consume 250 kilocalories versus just really tagging it like 0 to 4. Like I think that's my perspective as a user. Yeah, that's it for me, Val.
Yeah, definitely. Thanks for the comments, Ken. No, that's really something that we can take into consideration for our next iterations. And I agree with what you said that people can appreciate our classification of the different threshold values, because at the MVP level of our recommender engine, really our main goal was to deliver our value proposition, which was the threshold values.
Thank you very much for those very helpful inputs, Ken. And definitely, I think hearing from Basti that these will be used in the next iterations moving forward. Do any of our judges have any more comments? Bash, you're unmuting. Go ahead.
Okay.
Or did you stuff?
No, sorry. I thought I was on mute. So my question is, so this is a recommendation engine. Aside from getting inputs from your users, how do you measure the performance of that engine?
Yeah, there's different ways to measure the performance of our engine, but I guess something that I can say is what that Ken already mentioned is the user experience, because based on our research, really to test the performance of a recommender engine is to test it from a user's perspective. And since our value proposition is, aside from the threshold values, is that we don't compromise your preference of ingredients. So in terms of testing the performance, we can do user testings in the user experience side.
Aside from user testing, because user testing is very subjective, any other objective way that we can quantify the performance on a algorithmic way? Any things that you encountered in class that might help you? Starts with letter N, maybe?
This is actually a test of the 12 weeks.
No, I'm just kidding. So one metric that you can also like consider is applying, of course, my favorite, network analytics. There was a published paper from Nature by one of my favorite scientists, Albert Barabasi. We discussed him in class. He created, together with his colleague, a paper to like create a flavor network that captures flavor compounds shared by culinary ingredients, incorporating cultural nuances in data.
Hello?
Using... Sorry, can you hear me?
Yeah, you're back, Bash. And then we'll go to
sorry.
Ken after because he's raising his hand. Baka may idagdag si Ken. Yeah, go ahead, Bash.
All right. So I was mentioning that this paper from Nature by Albert Barabasi is really like one way that you can augment the models that you're using, because what they did here, if you remember our network theory class, you can use centrality measures to say that the recommendations that you are doing are coherent. So now we have like a number that can justify the performance of our network. So many cool like plots that you can also generate to just showcase, for example, a particular meal, how is it like related to other meals in the network. So that might be like a good visual way of showing to your users as well, not only a snapshot of what they have currently, but a set of different like ingredients or things that they can like see. All right, yeah, I think that's all for my point. But this is one way that we can objectively like capture metrics for our recommendation engine. Yeah, that's it.
Thanks for that, Bash. Ken, baka may gusto kang idagdag.
Yep, I actually want to challenge in terms of like the user experience for the recommender engine, because from what Bash stated earlier, it's really more objective and it's like a lag measure, or it's a lead or lag measure. Like it's the end measure for you to get more of a it's like an end measure that you get them to try it for you to really get like an output coming from your test. So like my question was more, I was very focused on your F1 score in your presentation earlier. I think this is related in terms of like how you could check it. Like how can you really improve your F1 score in your model for this? Like is there a way for you to be able to improve that coming from like a training or some sort of like an iteration in the models that you're currently using?
So for that one, we use the SVC model. So the F1 score is quite low, yeah. But we haven't tried yet the cross-validation methods in hyperparameter tuning. But aside from that, we also wanted to explore like how we could improve the vocabulary, because there's just a lot of specific ingredients, and that may play a part on the accuracy of our models.
That's something that's very interesting to hear from you to really proceed into more of a like another set of model. Sorry, last question, Val, for me. I'm very curious in terms of like your input ingredients. How many, as a user, how many can I actually use from like the website that you are using? Like this is what I'm seeing is chicken and then a vegetable. How many? What's the maximum that can be inputted here in terms of like usage?
So for that one, we haven't yet tested what is the maximum amount of ingredients, but our recommender works by having classifications, and from that one we filter using ingredient matching. So like for example, there's just a lot of different combination of ingredients, and there's a like many ingredients, the recommender might not provide the like the best match, and aside from that, it might not return a result if there are so many ingredients. So our recommender is just provides these suggestions. It works best for just a few ingredients as of now, as of the version that we implemented right now.
Thank
I
you,
think that's on.
Gray. Ken, sorry, we're time's up right now, but we're out of time right now. But hopefully we will get to we after this we'll have a breakout room session with our judges and participants for any other added comments. But for now, if we could give a bit of a time for Caleb and Finn, if you have any questions to catch up on or concerns, recommendations for Team Go Healthy. No, it's fine, Ken. It's fine. I understand that we have so much to give, so it's totally fine. Yes, go ahead, Caleb.
Just super quickly, I guess I found it really interesting. One of the recommendations being around the names of ingredients, maybe sort of looking at that in Filipino. Do you think that that could change a bias in the data set in what you originally collected, or would you maybe look at synonyms with different ingredients in terms of how you apply it?
I think if that suggestion would be applied to the current or to the next iteration of the app, where there's already a synonym for Filipino ingredients like manok is chicken, I think a neat fix that would preserve the integrity of the models, or like isolate the model, so that there would be no more retraining, or in the definition of the features, like we preserve the features integrity as English words. It's just a simple translation of input, so it will read the input of ingredients, and if it senses a non-English word, it will just clean that input so that all of the input are English words. I think that's the best, or a simple way to address that. But that's actually a really a good suggestion to increase accessibility of the product.
Thank you, Francis. And thank you, Caleb. Sir Finn, did you have anything you wanted to add just to close off this Q&A session with Team Go Healthy?
What interested me was the use of PCA prior to computing the threshold values. So I'm wondering if you reduce the dimensionality of the ingredients prior to computation of the sodium content, cholesterol, etc., you might exclude some ingredients that are energy giving, or exclude ingredients that when cooked together with other ingredients would transform simple sugars to complex sugars that would add to the threshold values. Maybe you can also take a look into that. Making sure that you don't remove ingredients that will later on add to the four categories that you're looking at.
To answer quickly, the PCA was only done to reduce the features or the ingredients that would not help in defining a recipe, but they were not reduced, or that they were not eliminated prior to computing the nutritional thresholds. So all of the nutritional thresholds are as of all of the complete ingredients, and the PCA was only done to focus on the ingredients which would be helpful in defining a recipe.
Thank you, Francis. Finn, yes, thank you so much. In the interest of time, we would have to cut this Q&A, but I understand that this is a manifestation of how invested everyone is, all the groups are, and especially the judges, in trying to give their inputs and suggestions to make sure that the capstone projects come out of this fellowship in the most polished form. Thank you so much to our panelists, Caleb, Bash, as well as Sir Finn and Sir Ken. Maraming salamat po. And thank you so much to our Team Go Healthy as well. Congratulations, you are finished with this Q&A and presentation. All of you, you have been such a great audience tonight. I'd like to give our fellows, our panel, and you all, our audiences, another big round of applause. Since we've been given too many applauses tonight, let's give hearts. Oo, kasi kulang na yung pagmamahal sa mundo natin ngayon. So let's give hearts, unlimited hearts dyan, heart reactions over Zoom. Thank you so much for spending your Friday night with us. But before that, before we close off the night, the Eskwelabs team has sent over a short feedback form and launched a Zoom poll for your comments and feedback. Yan, I see the hearts. I love it. Kulang na tayo sa mga hearts lately. We take your feedback very seriously, and we will be using this to improve our events in the future. And that is why those who will answer, those who will answer, listen to this, those who will answer the feedback form will receive an exclusive 50% off Aral Aral Plus. You can get your promo code in the confirmation page of the submitted Google form. So make sure you definitely, tell us how we did through the feedback form. It's bit.ly/DSC8 Demo Day Feedback. Also, and we'll send that in the Zoom chat in a while. Also, if you enjoyed the presentations today and you're interested in learning more about our program, we have the Data Science Fellowship Open House happening this March 17, 2022 from 7 to 8:30 p.m. And not only that, we have an open review session for aspiring fellows this coming April 6, 2022. You can already sign up. There you have it. The polls are up, and it would be great if all 49 of you can answer those poll questions. You can already sign up for both of these free events, and we are hoping to really see you all there. So again, the Zoom polls are up. Now, to close off our demo day for Cohort 8, I'll be handing the virtual floor over to Caleb Tuddy, our CTO and co-founder. Caleb, go ahead.
Thank you so much. And on behalf of the Eskwelabs team, thank you so much to our audience for joining us tonight. Special thanks to our panel, Eric Tria, Irvin Liu, Ken Lebranza, Finn Menezes, and Bash Umol for your insights and questions. And thank you as well to our host, Bel Vistel. And for those interested in applying for the Data Science Fellowship, you can already sign up for our next event. the open house, and the review session. The next cohort will start on May the 16th. Have a good evening, everyone.
All right, thank you so much for attending the Data Science Fellowship Cohort 8 Demo Day, Reimagining the Future with Data. Ayan. Don't forget to share your feedback through with us through the poll and feedback form. You can also reach out to us on our social media accounts and emails. Our next cohort is already accepting applicants, so we hope to see you in Cohort 9 of the Data Science Fellowship, and we will see you again in our next events. Thank you so much, everyone. This was your host, Val Vestille, saying love one another, be kind to one another, and vote for the right people this coming May 2022. God bless everyone. Signing off. Mwah.
Thank you.